So can you see my screen?
Yes, we can see.
Okay, that's great. So good morning, everyone. I'm really glad to be here today to present one of our projects at the MBRC lab. This research titled Geospatial Multispectral Analysis for Earthquake Assessment, Case Study over Fujairah, UAE. Actually, it's a collaboration work between different universities. The main host is the MBRC lab at University of Dubai, and we work together with the University of Sharjah and Pennsylvania State University. This is the outline of today's talks. I will start with a brief introduction of earthquakes, then I will state the problem we have, the study objectives, the material used. After that, I will go through the methodology, the results, and finally conclusion. So what's earthquake? Earthquake is the shaking of the Earth's surface, happened when a sudden release of energy in the lithosphere, which creates a seismic wave. We can describe earthquake by its magnitude, speed, frequency, duration, and epicenter location. Earthquakes have a great effect on human lives and economy. The left image here shows 2008 Sushan earthquake. The middle image shows the horrifying aftermath of 2018 Alaska earthquake, where it's greatly affected infrastructure. The right image shows the economic aftershocks of Nepal 2015 earthquake that continue to be felt for years later. So let's talk a little bit about the problem we are facing in UAE. Even UAE has been described as a low seismic activity area, but its location near major faults and active seismic sources, moreover, its rapidly growing population, along with its huge financial and economic investment, reveals a critical need to study and examine the region's seismic risk. Therefore, our study objectives are to map and identify different factors and their weighted contribution in the seismic activity at UAE, to perform a spatial porous statistical analysis for earthquake events along the Arabian Plate, to use analytical hierarchy process AHP along with weighted overlay analysis to generate a seismic hazard zonation map. Using the seismic hazard zonation map along with HP and machine learning will help us to identify and locate high risk areas within UAE. Materials, our study area, as you notice, it's the United Arab Emirates. It is located at the southeastern end of the Arabian Plate. It shares more than 650 kilometers with the Arabian Sea, and its current population is around 10 million. The data used in the study is first the earthquake catalog. It was prepared by Dr. Def, and it covers more than 115 years of earthquake events around the Arabian Plate. We also use the digital elevation model from USGS, Landsat images also from USGS, UAE soil hard copy map, build-up area, road networks, schools, and hospitals for Fujairah, downloaded from the OpenStreetMaps. The research methodology, it's mainly consists of three parts. The first part, we will generate a seismic hazard zonation map to locate the highest hazard emirate in UAE. When I say the highest hazard emirate in UAE, it's somehow a relative relationship between the other emirates. As you remember earlier, I said that UAE is considered as a low seismic activity area when we compare it to other countries. After generating the seismic hazard zonation map, vulnerability and risk analysis will help us to locate the highest risk zone within that emirate, and will help us also to generate the risk maps. So let's go through the process of generating the seismic hazard zonation map. To generate the seismic hazard zonation map, 3 steps has been followed. First, collecting the data, the spatial data, then data processing, and to get 5 factors or 5 maps. These maps will be weighted, reclassified, and ranked using HP to generate a seismic hazard zonation map. I want you just to keep in mind that we use 5 factors to generate the risk maps. To generate the seismic hazard zonation map. So here's this slide shows the 3 factors out of 5. The first one to the left is the slope generated using a digital elevation model. The middle map shows the geology map, where we generated using Landsat images. And the right map is the soil, UAE soil map that has been digitized manually. Actually, this map here shows the methodology where we create the two last factors. The fourth factor is the distance from the fault. As you can see here, the two major lines which have the direct impact on the seismicity of UAE. They were manually digitized, and then we find the distance from these faults to UAE. You can also see the earthquake events categorized according to its magnitude. So now let's talk about the fifth and the last factor toward the seismic hazardization map, which is the peaky ground acceleration map. First, earthquake events for more than 100 years have been plotted, and then kernel density estimator was applied to create a continuous surface of earthquake density based on the magnitude to show the location of the most powerful earthquakes. Kernel density shows a peak, as you can see here, at the location of the event. This peak decreases until it reaches zero at a specific surge radius distance. After that, local Morans I was applied to locate the spatial clusters. Positive values of local Morans I, as you can see in the blue and the red, that means that the event has a neighboring event with the same high or low attribute values, and it will be considered a part of the spatial cluster. On the other hand, if we have negative values of local Morans I index, as you can see in the green and the orange, that shows a different values of neighboring events, and it will be considered as outlier. Moreover, p-value must be examined. P-value should be less than 0.05 to consider a statistically significant sample. Next, JITIS or G-star was applied to navigate each area based on a set distance. It also generates a z-score, statistically significant positive z-score, as you can see in the blue, in the red. It means a hotspot. The higher the score, the more intense of clustering of hotspots. On the other hand, statistically significant negative z-score means cold spot, where you can see the blue color. The lower the z-score, the more intense of cold spot clustering. From the hotspot map here, we can locate 3 hotspots. So the distance from each hotspot, along with the value of the highest earthquake magnitude in the catalog, was used within the attenuation relationship here to create the peaky ground acceleration map. So what we mean by peaky ground acceleration? Peaky ground acceleration is equal to the maximum ground acceleration that happened during earthquake shaking. And we use the attenuation relationship to describe the decrease in the peaky ground acceleration for an earthquake with distance from the epicenter R. This slide here shows the resulted peaky ground acceleration map. After having all the 5 factors in hand, AHP was used to weight these factors. AHP helped us to rank objective and subjective factors. Then to generate the pairwise comparison matrix, weighted overlay analysis in GIS were used to generate the seismic hazard zonation map. As you can notice from the map, Fujairah Emirate is located within a very high hazard zone. Again, it's just a relative relationship between the other emirates. Therefore, vulnerability and risk analysis were carried out to locate the highest risky areas within Fujairah. Here's some images for Fujairah, and you may notice that Fujairah is a highly populated area, and the residential areas and the populated area is somehow trapped between the mountains and the shoreline. And now for the risk and vulnerability analysis part, it's also divided into 3 parts, collecting the data that include digital elevation model, road network, residential areas, schools, and hospital locations. Then data processing, where 8 maps have been generated. as you can see here, to be weighted and ranked using AHP and machine learning to finally generate the risk maps for Fujairah. The slide here shows the data used for the vulnerability analysis. To the left, you can see the residential areas downloaded from OpenStreetMaps. The middle map is the roads, also downloaded from OpenStreetMaps. And the right map is represent the streams where hydrological analysis has been carried out using DTM to generate this map, the stream maps. To the left here, you can see the location of the hospitals, and to the right is the location of the schools, where we consider it as evacuation areas. For data processing, DTM was used to generate the slope map. To the left, you can see the classified rank slope map. The middle represents the classified rank distance from the streams, where again we use hydrological analysis to generate the streams and then finding the distance and then ranking, classifying and ranking. The map to the right is the classified rank map, distance from the road. Two maps here shows the classified rank service maps for hospitals and schools. This slide shows to the left the classified rank distance from the shore map, and to the right is the raster map of the residential. DTM was used to generate the eighth and the final factor towards the risk map, which is the trapped area between the sea and the mountains. This map to the left shows the rank confined trapped area. Using AHP, all the 8 factors were classified and ranked according to expert opinions and literature review. After creating the pairwise comparison matrix, weighted overlay analysis and GIS were used to generate the Fujairah risk map. To classify most risky zone within Fujairah, 3 machine learning models had been utilized. First, support vector machine, decision tree, and random forest. 500 points across the area had been manually examined and selected to train the machine learning algorithm. Each thematic map you saw earlier, or each factor, has been considered as independent parameter, and the potential risk was dependent parameter for the machine learning model. 60% of the data categorized as training, while 40% as testing. Support vector machine, as you can see from the table at the top, presents the highest accuracy of 79.6, while decision tree shows 78.9%, and random forest shows 78.2%. Support vector machine draws a standard deviation of 6.5%. The lower table here shows the confusion matrix accuracy of the same model. The predicted high is almost 88%, representing the testing and the training datasets. The figure here represents the comparison of the weights of each input parameter resulting from AHP and machine learning techniques. Differences in weights can be observed using both techniques. For example, in AHP model, the highest weight has been assigned to the roads. Then the same weight of 20% has been assigned to the confined area and the residential. On the other hand, machine learning moderately assigned more weightage to the evacuation centers, such as the schools and the hospital, distance from the schools and the hospitals. The weight assigned to the distance from the shoreline, as you can see, it almost doubled using machine learning. The slide here shows the risk maps that were obtained by multiplying the hazard and vulnerability. A to the left represent the pairwise analysis model, which is HP, while B represent the support vector machine. I will talk more in details about these resulting risk maps. For the results, according to the created seismic hazard zonation map, UAE had been divided into 5 hazard zones ranging from very high to very low, where the effect of peaky ground acceleration, slope, and distance from the epicenter reach its highest at Fujairah and Old Ras Al Khaimah. The effect of geology and soil reach its highest in the middle and the southern part of UAE. The very high hazard zone covered a very populated area within Fujairah. So now you can see the resulted risk map, and what we can conclude from this map that for zone A here, it's a very high risk zone in both approaches, and it's located in Fujairah northeastern part. It's very close to the shoreline, and from the images you can notice that it's an industrial area, compact industrial area. It's also bounded by mountains from the west and Gulf of Oman from the east. Being an industrial region makes it very hard to evacuate during a disaster. Zone B shows identical pattern in both outputs. In HP, it's very high, and machine learning considered under a high risk zone. This zone is also a confined area with the mountains from the west, and it has a compact build-up of residence. It's also closer to the streams from the mountains. Zone C is a combination of confined and residential area, making it a very high risk zone in HP and high zone in machine learning. Zone D here is another high risk zone with similar contributing major parameters, same as A, B, and C, such as its closeness to the residential, and it's also a confined area. Zone A is considered as a low risk zone, even it's a very close to the shoreline, but the other contributing parameters, such as the availability of evacuation centers and a good coverage of roads, minimize its risk. Zone F is a moderate risk zone. It's close to the streams and it has a higher slope, but since it doesn't have evacuation centers, closed evacuation centers, it's considered as a moderate risk zone. Zone G is a high risk zone using machine learning, since the machine learning assign more weight for the distance from the schools and the streams compared to AHP approach. To conclude, half of the study area is located in the low hazard zone, while almost 11% of the total study area is a high hazard zone, 20% under moderate hazard zone. From the seismic hazard zonation map, the coastal and the downtown areas at Fujairah are most vulnerable. Risk map were obtained using AHP and machine learning techniques. The support vector machine model showed the highest accuracy of 79.6%. The resulted risk maps were categorized into 5 risk zones: very high, high, moderate, low, and very low. Almost 20 kilometers square of Fujairah Emirate can be considered as very high risk zone, while 114 kilometers of the Emirate is under high risk zone. I'm happy to announce that this research has been published twice, first at the ISPRS conference and recently in Journal of Sensors. Thank you for listening, and I will be happy to answer any question you have.
Thank you so much, Engineer Diena, for your fruitful and constructive presentation. And now we will leave the floor to our audience to ask questions and start the discussions. I can see a couple of questions from Ali. Ali is asking, what is the minimum magnitude in your catalog?
Actually, it ranges between, very low, I think maybe 1, and the highest, I think it was 7.3.
Okay, and the second question is, which GMPE used in the study?
GMEP?
Yeah, GMPE.
What do you mean by GMPE?
No idea.
So I'm not sure if you can explain more about his question.
All right, and here Khalid also, Khalid Al-Blushi, he would like to say something. Hello, Khalid.
Hello, Assalamu alaikum.
Salam.
Walaikum salam.
Thank you for sharing us your effort and this interesting topic. Myself, I'm wondering about the map you just show us about the hazard. If you can
you
go
mean
back to it.
the seismic
The
hazard zonation map?
Zoning map, UAE zoning map. Sorry for that, if you go back.
No, sure, I'm trying.
So,
Okay, so I think you mean the seismic
this
hazard
one,
zonation map.
yeah.
Yes, I have a slide which is it's bigger.
Yes, at the beginning. Yeah.
Yes.
Okay. Here, as I understand, the highest risk is in Fujairah city, right?
Yes, you're right.
Yeah, but lately, as you said, we are away from the earthquake zone. What means the epicenters are not in UAE?
Yes, the epicenters are not in UAE. Actually, the epicenters.
But yes. What if we have an area with 6 epicenters comparing to Fujairah with any epicenter? So still Fujairah is the highest risk?
I'm sorry, I can't get your question.
Okay. Let's say we have an area X somewhere in UAE.
Yes.
It has during the history 6 epicenters. So it's generating earthquakes. While in Fujairah city, there is any epicenter. So
actually, it depends on where's the exact location of the epicenter. As you know, the epicenter is somehow close to the fault lines. It's it's away from UAE. Because of that, we say UAE is a low seismic activity area.
Sorry, Gina. We have epicenters in UAE. These are regional zone, but we have some local zones within UAE. I was looking for you to mention that Diba zone, Ham zone, Hatta zone. During the history, we had significant epicenter in 2002 in Masafi, in 2007 in Hatta. But lately, it's something really weird. We have 5 epicenters at the same area in 1 month, which is really unbelievable. And
actually, so I would appreciate if you can share this information with us.
It's announced in public. If you follow up the news in Google, you can find them.
The only earthquake that affected UAE was, I think, in maybe 10 years ago, where you just mentioned Masafi. And I'm not sure.
No, that was in 2002. No, but you are talking about the risk, a potential of risk. So here we have a active fault zone. On the top of this fault zone, we got 5 earthquakes in 1 month, if it's not 6, in 1 month this year. And the Diba fault zone. Yes, it's 60 kilometers north of Fujairah, of your high risk area. So I think in DEM of UAE and a structural map, not geological map, it will help you a lot in this study.
Yes, you're totally right. If we have the right information about the earthquakes you just mentioned.
Yes, you can go to the meteorology center. They provide on their website all the earthquakes. But this one really was a big alarm for us in UAE to attention to it. It's 5 or 6 earthquake within diameter of 10 kilometers.
And do you know
top of the project.
Which Emirates were most affected by that?
No, not necessarily the Emirates to be affected. But there is a movement, there is a motion. Earthquakes, you don't know, you cannot predict. It may happen a significant, la samahallah, or maybe small. But when you have this high frequent, it's really something alarming and require a lot of study from geology part, seismology part, geophysics, remote sensing. All these should focus on that. It's really a big alarm for us.
Yes, you're totally right. Actually, what we use in this research was all open source, data. and we would appreciate if we have like
and small
more
advice,
meaningful.
if you accept it from me.
Yeah,
Focus
sure, go ahead.
on the three main structure, which is branch from this regional. Hatta, Ham, and Diba. These fault zones are not only fault, it's zones. These are the source of the earthquakes in UAE.
It's
So
Hatta almost
Hatta,
here, right?
Hatta down, but this is where you are pointing is Diba.
Diba al-Husab.
Diba, yes. There is the whole region, 3 dibas located on the width of it 5 kilometers, and it's channeling fresh water from the mountain to the sea, and it's active. We have evidence
really,
on that one.
Yeah, that's really good information, and for sure, Yani, I will go back and look into this.
I will
data.
send you an email so
yes.
I can share you some studies also.
Yeah, that would be great.
Thank you.
I would appreciate that. Thank you.
Thank you.
Okay, thank you so much, Mr. Khalid. And now we'll give the floor to Abdul Qadir to ask his question also. Hello, Abdul Qadir. Yes, Abdul Qadir, you can talk now. Engineer Diena, I have also a couple of questions for you.
Yes, sure.
So in your study here, you relied on 3 machine learning models that are the support vector machine, decision tree, along with the random forest, without considering one of the traditional machine learning model, that is the artificial neural network. So is there any reason behind that?
Actually, I'm not expert in machine learning, and I use software for that. So I tried these 3 according to literature review and some work done in earthquakes, and I think I got fair enough good results.
Right. How did you evaluate or how you actually validate your results?
Actually, the problem is here because we don't have any data on earthquakes and how they measure it around UAE, and if they have proper emergency management procedures. So it's a research, and as Mr. Ali earlier told us, that there's more information. We can enhance this research by using more, good information about these things.
All right. Mr. Ali here would like to say something. Hello.
Yeah, assalamu alaikum.
Yeah, salam.
علي مجاهد من المركز الوطني للأرصاد. مشكورة جدا على البرزنتيشن وشغل كويس. كان في ملاحظة بس إنه الكتالوج لما أنا سألت على المينيمم ماجنتيود حضرتك قلتي 1، فمن وين يعني السورسز اللي هي ماجنتيود 1 فيما فوق؟ اكيد المركز الوطني للارصاد بالامارات هو اللي بيسجل الزلازل بالقوه دي. فيفترض انه الزلازل دي حضرتك تكوني اخذه الكتالوج من المركز او الداتا كلها اللي متسجله من المركز.
شكرا لسؤالك اول شيء.
بس اكمل
تفضل.
الله يبارك. لانه يفترض انه الكتالوج من المركز يعتبر كامل وموجود، هو متاح لكل الجهات انهم يستخدموه، وهيودي حضرتك فكره اكثر عن التوزيع النشاط الزلزالي على مستوى الدوله، والسورس زون اللي موجوده كتير، اللي هي موجوده في البيبر اللي حضرتك استخدمتها بتاع الداما باستوس وباكوتشي. فالاثنين حاطين سورس زونز اللي هي مثلا زي ما الدكتور خالد قال، اللي هو الزون بتاع من الفوجيرا مسافي دبا، في اكتر من سورس زون فيه. هو ده اللي ممكن وحصل عليه زلزال 2002 بقوه 5 درجات، ومحتمل ان يوصل ل6 درجات في المنطقه. كهازارد ماب. في السورس زون تاني اللي هو بتاع مكران حصل عليه 8.1 في 1945 وحصل منه تسونامي. ده سورس زون واحتمال يسبب تسونامي لو حصل عليه زلزال كبير، وبيحصل عليه زلازل بقوه قليله برضه. كلها ده موجوده في الكتالوج بتاع المركز الوطني للارصاد، اللي هي دي زلازل مش هيسجلها غير مثلا الكتالوج العماني او الكتالوج الاماراتي للزلازل، وخصوصا للزلازل القوه بتاعتها قليله. القوى اللي فوق الاربع درجات او 5 او اي قوه خارج دوله الامارات العربيه المتحده هتلاقيها في الكتالوج اللي هو بتاع العالمي او الكتالوج الايراني اللي موجود برضه بابلشت على الانترنت. ف بالاضافه للكتالوج فيه الجراوند موشن بريدكشن ايكويشن، لان احنا في المركز عندنا داوت كبير على انهي جراوند موشن بريدكشن ايكويشن تستخدم على اساس ان احنا نعرف الهازارد على الدوله اللي بنطلع منه ريسك. فدي محتاجه احنا بنحاول نوصل لجراوند موشن بريدكشن ايكويشن كويسه بحيث ان احنا نوصل للهازارد هيبقى ايه، البيج جراوند اكسلريشن اللي ممكن تكون موجوده ايه، وبنضيف محطات لتسجيل الاكسلريشن. حاليا بنزود الشبكه الوطنيه وبحيث ان احنا يبقى عندنا بيانات متاحه للانجينيرنج ومتاحه للدراسات الخاصه بالكود كود الزلازل على مستوى الدوله. احنا مش بنتكلم على امور معينه، لان الزلازل مش هتقف، الويفز مش هتقف، لا تعترف بالحدود لا ما بين الدول ولا ما بين فالتاثير بيوصل لاي مكان سواء كان بيت او قريب، واللو تارجت من الهاير فريكونسي بتاثر على ايه واللور فريكونسي بتاثر على ايه. فلو في اي بيانات حضرتك محتاج اي بيانات فيبقى في تواصل مع المركز، يعني هيبقى في توفير لبيانات اكتر للكتالوج لاي حاجه ممكن تحتاجها ان شاء الله في الدراسه. لو
أول شيء is if you're working in that center, I'm not sure what's the exact name of it. يعني we would really appreciate any kind of information you have, and for sure يعني we will contact you. I'm not sure if you have our email for Engineer Saeed or my email, because as you know it's MBRC research, so we would appreciate really any information regarding this issues. Your first question for the earthquake catalog, it was prepared by Dr. Def, and I think he's at one of universities in Iran. If you go back to the first paper, the geostatistical seismic analysis and hazard assessment for United Arab Emirates, we have a good explanation about the catalog. And we took 115 years ending by 2018. So we didn't take any earthquake after 2018. That. I'm not sure if I answered your first question regarding the catalog.
Yeah. NCM is starting 2007 or in the beginning or 2008. So
then it was for sure it was within the catalog because it has the whole the Arabian Plate area.
It will not,
the whole Arabian Plate area.
It will not contain any earthquake inside UAE because magnitude inside UAE is small and it will not be detected by a network outside UAE. So you will not find it outside in any other catalog. It's only in UAE catalog. As Dr. Khalid mentioned, smaller earthquakes was recorded by in National Center of Meteorology Seismic Network, UAE Seismic Network, and it will not be in any other catalog.
What about Oman catalog?
It's same. We are all same. If you got it from Oman catalog, it's the same. You got it from us. It's the same.
Then as I remember, I'm not sure of that, and I would appreciate really if you go back to this paper, because what he mentioned that he has many different catalogs and he made one of them all.
Okay.
So if you go back to this paper, you can see the more explanation about that catalog.
Excuse me?
Yes.
Hello?
Yes.
This is Khalid again. Sorry, what happened is good. Your study is perfect. But what Dr. Ali is saying, there is a big opportunity for you, maybe for the phase 2 or something. We have more accurate data here in the meteorology center because they have their own station. It's linked also with the Oman Center and University of Sultan Qaboos, Dubai municipality. So those will give you more accurate data.
Yeah, thank you, Doctor.
As a researcher, you should know these centers. you should contact them. Don't wait for them to send you any data. They have everything available in the website, or even those people are helpful. Always in my research, they provide me with all requested data. So it's good, like using this tool, remote sensing, for the such assessment. It's really perfect. But more accurate data will reduce the assumption and will give us better results in future, inshallah.
Actually,
so
this is our next. Yeah, this is our next step.
Yes, what Dr. Ali, I think, is trying to say, instead of going for the regional information, which is have specific range of magnitude, for the small magnitudes, which give you indication of this structure, I think the Meteorology Center will help you a lot on that.
Yes, that's our next step, and we will contact them to refresh this research again with the more accurate data. I'm not sure if there's any other question.
You can. There is some question regarding the ground motion prediction equation.
No. It's not a question. Hello?
Yes.
It's not a question, because when you said GMBE, I said it is ground motion prediction equation.
It stands for the ground.
Sorry, it's okay. Okay.
Yeah.
Okay.
Yeah, so I think here we came to the end of this webinar. Thank you so much, Engineer Diena. Thank you all for your kind interest in attending this webinar, and looking forward to meet you in our upcoming events. Thank you so much.
Yes.